Thank you for coming. My name is Micah Berninghausen, or I go by Game Dev Micah across some of the social areas. This is speeding up destruction for the Giantess Playground. Epic Game CEO loves this Giantess game. Now you can wishlist it. There's some cards out there you can see. It's a pretty cool highlight to go through. This talk, I'm going to go through some ways to speed up destruction. Now this doesn't mean that you have to make your entire environment destructible, but maybe some smaller pieces can be less of an impact. Or maybe you do want to make your entire environment destructible. I'm definitely going to be showing or talking about a lot of secrets. And if you want to know more about them, get a hold of me. Let's talk some more too. So let's move on in. This is who Micah is. Just a little bit of my quick history. Way back in the 1900s, I worked on Counter-Strike, Alpha, doing destruction. DE Dam was the game. And then after that, I went ahead and went over to Battlefield Vietnam, played esports there with Team Warchild for 3 years, dominated everybody. If you disagree, I'd love to talk with you. Let's go fight. I mean, par, that's it, yeah. Then after that, I did a data center career, which is down on the bottom there. For about 25 years, worked and grew the internet, grew clouds, high availability. Well, I talked about in the UFN talk earlier about how Fortnite works with the entire system up through Amazon. We're not gonna talk about that here, but I have that understanding. Got to take my mom down there in the corner to my kickoff for sales. I had a good career in sales. I love my mom. I got to take her to the beach. That's why she's up there in that photo. I do have my kids, Logan and Luke. So my wife and I are both nerds. So we got those wonderful names. My older children are over there. My 92 MR2 Turbo, an E85, and my 1972 Datsun with a small block 350 in it. The reason I show that is because those are cool things I'd like to talk about. So if anyone else wants to talk about that stuff, that's cool too. And then finally, the man himself down there has been following me for about 2 years now, since I've been going through this destruction that we're going to be looking at today. And I'm going to be showing all the stuff that he's seen. And now we're moving that destruction out of the matrix into the Giantess Playground, which we'll look at. So, and I'm also a freshly minted Unreal instructor certified. So that happened on the 30th. So I wanted to come and do these talks. So I figured I'd see if I knew enough. And they say I'm pretty cool. So that's been a huge honor. So live demo, it's a video. But this was recorded on my laptop, which is a 4060 with 4 cores, 60 gigs of RAM. It was $1,000 from Tough. Just to sort of give you an idea, it's about what a console would be. What you're seeing here, we're running around as a Giantess in the Matrix. This is the current state of the game, or as recorded on that laptop. And we're going to go through how we get to this point off of the Matrix, because the Matrix, well, it didn't do all of this. It did do the cars, the destruction on the cars we're seeing down there. It did have our metahumans running around, and they are now running around away from her. She can crush everything, pick it up, do all that type of stuff. And also, so we have some hide and seek is one game. Reach in, grab you as you're running around as a little person. So you got that escape. You got to try to fight away from her. Also, we're going toward just a rampage mode, which would be this. How much damage did you do? How over the time period, all this. And these are, works in progress on the different play styles. And then ultimately a army versus, right? Pretty much your Godzilla battle. So that's, what I'm sort of showing here is that all we need to do is put Godzilla, or when we already have, any mesh in replace of her, and we'll go through how we're waking things up, because it doesn't tie, we'll go through all that, so we'll watch this through. So what's going on as we scale her up, her sockets have wake-up points on them. I'm taking her sockets, and we'll look at it and waking up the ISMs, or instant static meshes, that are building up these entire buildings. Once we do about 60% of the damage to the building, I'll collapse the entire building. And then we'll see that in just a second here, because this is a pretty big building. It has the full interiors with stairs that have been matched to the windows, and an elevator shaft, some office equipment. We'll look at all that to give us a full populated interior. This converts over into Niagara, and really look at the shadows coming from everything falling. Since we're doing Nanite Niagara, so I'm going to go ahead and rendering all my GPU Niagara particles as nanite, shadows are cheap. And it's all in that one draw call. So how do we get here? Way back when I started, 4, 5, 6 years ago, there was a tech art video for UE4 where they had, hey, here's what ISMs do. You can get thousands of instances. And I'm like, all right, sweet. I was coming from Unity, coming over to Unreal, looking how instancing works here. But then they took the center point, which would be where the planet was, and just rotated the ISM. And I was like, boom, we can get transforms without doing it at each instance. So could we use moving ISMs to reduce the amount of pieces that we're simulating for destruction? And yes, we can. So I think this is one of the better movies out there, is 2012, for showing massive destruction. So I would watch that over and over again and say, what can I parallel? What can I batch together? What can I take out of the simulation? And and these were terms from enterprise computing. So I did 25 years of data center, so those are more mainframe setup, are always operational. So when I look at the video of the main destruction, you'll see a lot of free-falling pieces, bricks, chairs, tables that have stopped colliding with stuff, and now it just has to fall for a long time to hit the ground. But they're being simulated typically. Now I'll show the video here. And so I want you to really just be looking at, once things aren't touching each other, we get rotations, yeah, but they're just free-falling. Nothing else is going to interact with them. And so how can I do this runtime? Sounds like a big challenge, exactly what I wanted to work on. Hopefully it would get me talking here at some point, maybe selling games, and here we are. And so this is the goal. Not what I've made, this is the movie 2012, this is the goal, runtime. So falling ISMs was how I got there with this part. I've migrated off a bit, but I want to talk about falling ISMs. I made a system of 2 ISM instance static mesh components per mesh that would be offset. They would fall down, and I would just recycle them as I would put those free-falling pieces into it. From that, we would get unlimited falling, because once they're in the ISM, I've turned off all collisions, all updates that needed there, so there's nothing extra happening from the system. It's just the visual that we're seeing. You can turn those on if you want, but it's off for now. And that gives us this. So this is about 30 or less static meshes that are being spawned into these falling ISMs. We do a trace down or projection to see when we're going to hit the floor, and then we store when we're going to pull them out of that ISM. And this way, everything is, this is a small example, but this is from a 1080 Ti, and this is probably 3 or 4 years ago on UE4, actually. Yes, this is UE4. So this was before Nanite, so then this was really beneficial because we didn't have Nanite to play with. So I'm also using a CPU pool. So I'm taking, let's read this. Destroying the matrix, small awakened city level was working great. I used 6 to 1,000 static mesh components as a CPU pool of physics actors. I placed each CPU pool mesh where I needed to simulate physics, because this was before I was exporting to Niagara, to match whatever the mesh and material was at that rotation. And we'll look at a video on it. I would then assign the mesh I need and simulate it on the CPU. How they became falling ISMs is as I would wake up some instances to do my simulation, I would check them. Have you guys hit anything recently? Do you have any movement, X and Y? Or if you hit enough falling speed of Z to meet gravity, you're not spinning, you're not going anywhere. To go straight down, and I repool the CPU component and add the instance there. So in this wireframe that we're going to look at, green wireframes will be our CPU actors. Pink will be the falling ISMs if you see it moving. Pink, if it's not moving, has slept to a new sleeping ISM. And then cyan is all the world that hasn't been touched yet. And so all that pink I've woken up before. I'm putting a spear wake up in front of me that's then turning them into CPU actors. They'll fall. You see some of them will convert pink in the air and keep falling, and then convert to green on the ground and resimulate. I call this just-in-time resources, right? So, and this is good on it. You see them come down, the pink coming down, converting to green, doing the needed simulation. And because we're using ISMs, it's pretty much as efficient as you can get for all of it. Less components, least amount of components. I'll take a little drink here. So the problem with falling ISMs, sort of, is that you lose rotational speed. And so you will see that unless you go up there and update and rotate each instance, or use world position to do it, that they're just falling straight down. And we also turned off, like I mentioned, everything on them, like can step up on, does it have a collision, just to reduce any checks every frame on those components. because I know when I'm going to resimulate them. And I spoke about doing that cast down to figure out when we're going to hit. So when the falling ISM lands, or that instance is projected to hit whatever the surface was below it, because we did that line trace, but whatever trace channel you want, it provides fine placement at each one of those locations when we do the resimulation through the CPU. So for faster sleeping on demand, let's say that you are past that 1000 CPU, or your frame rate's just low, you can just sleep directly to an ISM rather than doing the simulation. What you could also do is store another ISM, which is your non-slept or non-finally slept. And when you have extra cycles, you have the CPU back, go out and sleep those things. And of course, the further away you do that, keep the CPU close to you, keep sleeping everything close to you, and the far away things are less noticeable, so you go about fix that up after time. So putting the resources where we want them is the whole goal here, which is right around the camera and where the destruction's happening. You can wake up from the ISMs that are falling. So I mean, if you had somebody walking through these falling ISMs, you don't want to wake up and resimulate CPU. So you can go ahead and grab them out of there, but you'll want to take it out of what I'm doing is something called group time. It's an array of arrays of IDs, and it's based by the time that's projected to, the group time or the game time seconds that's projected to hit the ground. That way I don't have to look at all of my array to find out what instances I would do right now. I can just look at their game time IDs to make sure I just take any game times that have ticked. So it's just efficiently not to go through all that list. So Tim saw it. I regularly post on Twitter, as you may know. I have more posts than the owner of Twitter, which was depressing to find out. But Tim saw it, said it looked amazing, and we're going to go ahead and look at it. And he followed me at that point. So absolutely. As this is speaking to all of you, so thank you for coming here and helping me with this. So let's watch the video. So here's what we were seeing in the wireframe, but just done fully shaded. What I'm doing is I'm waking everything up, and if I have the CPU to simulate it, it gets to simulate a little bit to give some motion. Then it's converting over to falling ISMs, and it's falling all the way down to where it's projected to hit on a plane I had below. And I'm doing this for everything. There's no interiors yet. And what I do also at this point is that our buildings are different ISMs, different ISM components of a lot of the same meshes. As it goes into my system, it does go into just one ISM. And as you get those ISMs large, I find out that, well, they start taking more and more time to put pieces in there. So you do have to start segregating and writing them out. And so I then end up rolling my own world partition grid hash system to store this stuff and load in and out. But this is on a 1080 Ti, at 1080p, and it's just as many as I want. So this was super cool, but it was my system, right? And I'm a big believer in using Unreal's tools and their staff rather than Micah, just because I'm one person. I don't, let myself take vacations. So we need interiors. The Matrix Awakens buildings didn't have any floors, but they're constructed with optimized ISM components. So we need to add more ISMs for the floors, the stairs, the elevator shafts, lights, office equipment, stuff like that. I started off by doing this by just saying, okay, can I just put some cubes inside the buildings? Just start to see how I'm going to do this procedural generation through Blueprint, just to show I'm getting that thickness of having something inside my buildings. And then that turned into, of course, a month of playing in blueprints. And what you're seeing here, they all had interiors. I'm runtime generating interiors for these using blueprints and traces to actually trace out a floor. I'll put a grid out there about the size of the building. Do traces up from each tile that I make my kit bash floor out of to see if it can hit the sky. If it can hit the sky, it's outside, and delete it. Do that on up, build my floors, and a whole bunch of, this is a couple talks to go through this detail, but you can see that now I have interiors through this, our overlapping view, or our nanite overlap view, that everything's there. And of course, this is my test area, and we'll go look at the entire 611 buildings generated in the Matrix Small City next. But just seeing that there's floors everywhere, they're matching to the windows. The center there is a stairwell and elevator shaft we could use. And so you can actually go in the front door on the bottom story and go all the way up to the roof of all the buildings down. And so 80 Level saw that, and they retweeted it. That was really my first time in contact with them, so that was beautiful. And they retweeted this video. So this is the entire small city level with interiors in it. And we'll just fly through them all to show they're fully loaded. So there's no world partition in use. So there's no grids. It's my own system. So everything is loaded. All the components are here. All the ISMs are here. And they maintain here. So you'll see in that video earlier when we did destruction, if we were to leave and go off to the beach or out in the water and look back at the buildings, they'd all still be destroyed in Nanite. And so this took 6 minutes to generate all the interiors in blueprints as you're playing the game. So I dithered it to spread out the load. So it could probably be done a lot less time than that. But I was thinking all the data involved in storing the interiors, I was wondering if that would be an issue to have in the level. So I figured I'd try and put it off into a save file or generate it at runtime. And now I have these save files. I can't get them into the level. So, I had to figure that stuff out. But that was super cool. I got to meet JS and Julian of the PCG team, because this was just when procedural generation was coming out. So of course I'm like, I love using Unreal tools. So can I use PCG? There was no need to read back from the environment at that point. So I couldn't do line traces out to get data to build mine. So I'm like, but you guys, they're amazing stuff. So amazing. Micah, get back to it. Okay. So then we went to speeding up. So I was flying around with my superhero size, and I didn't like that we didn't have fine breakup, fracturing like the geo collections would provide you. So I kind of thought, well, let's start getting the character a little bit bigger and start doing a bus type of game. And this is sort of the end of where the bus game got to, is I have tons of metahumans out here. They're using, what's it? I forget, I'm spacing on the name, but when you do the animation moves you. That's how I'm doing it right now. I'm spacing on that term to actually move them around. And so I'm not ever touching mass. Mass doesn't know what's going on. I'm just moving the AI around with these animations playing. And this is probably 5.3. And our current Giantess is in 5.3 as well. So we're going to have a wonderful improvement going to 5.6. And I did bring this all the way up to 5.5 at Unreal Fest. All of this snow you're seeing out there is a single material, single mesh. And so it's one draw call. I'm actually doing decals that way. So I snow down particles from Niagara where the particles die. I then I spawn another particle in Niagara, which is a cube that is my snow mesh. So this is the real snow too. This is kind of fun, or replacement. So then somebody said you need to make a Patreon or a PayPal. I'm like, okay. And then he sent me $1,000. Great day. I've been helping them in DMs with the Giantess Playground. And so they just said, thanks. Next thing I did was say, okay, well, let's try consulting, right? And because in the data center space, I know there's knowledge to share. And Tim was like, yeah, this guy. And I'm like, hey, wow, that helps with the imposter syndrome. So I made a lot of friends. Hopefully you notice some of these faces across here are some great mentor of mine, some of the most great creators that we have here. I know one of them just got promoted to a principal role, so that was super cool. And then there's even that guy I'm holding up. So, and these are some more creators as well. There's a little dude down the bottom too. But I'm just like, this is my passion. I'm doing it because I want to be able to tell my sons that they should chase their passion. And it's going well, so thank you. So, it doesn't mean you're a client though. You may just be a really cool person, so thanks for the friendship in those photos. We moved on to asteroids. In Seattle, I think it was the Cassini project, PCG with the asteroid ring. And so of course I got to see Julian and JS up there and see that demo. I said, okay, I'll destroy it for you. So this is 16 million instances in its own little grid setup around that Saturn. And so we're just here asteroids, waking them up out of the ISM, sending them to Niagara, because we're going to use Niagara now to simulate instead of falling ISMs. And this got shared by 80 level as well. And I was like, we're going to surf around here and just send a big old wave out of asteroids in the air. And so just the main part here, of course, is since it all writes back to ISMs, As we fly, and it's all nanite. We're not using any age logs or any world partition going on. You can see other marks out there that I've done carving into the asteroid field as well. So it's about seeing what you're doing, seeing your destruction for the entire level. And then we move into speeding up destruction with Giantess Playground. So, and Tim had commented on Twitter that it had nice destruction, and then Vice went ahead and got him on that. So that was pretty cool. So down here, there's level 80 was sharing one of my posts. Tim's post there. Oh, I'm looking for far away. I retweeted an Unreal Engine 5 game that has awesome use of the destruction system. And that's me getting back into using their systems. And this is a news story. Well, at least they didn't interpret my retweeting the chicken dancing video the same way. So I went ahead and jumped on that and put in an Epic grant. It's my second time putting in a grant for the game, a request. So it's still pending, of course, but I'll just let you know that. So to follow up on Tim saying I'm using the destruction system well, I'd love some help in accelerating that. And that's where I found this guy up here in the front row. But he's another destruction expert like I would like to become, I'll say. And let me show you what he's been up to, Michael Royalty. These are instance static meshes of bricks. He's going to run through and start simulating these bricks off to the GPU. And the neat thing about bricks, of course, is on the GPU, you're dealing with a sphere, right, for simulation. But your brick is not a sphere. He's changing the size or the scale of the sphere as the brick rotates to let the area it's touching on the ground make it look like it's the right touch place. And he's doing it for a lot of bricks. So this would be heading towards the direction I need, which is fine destruction instead of my big pieces. And then another video you have, which is really nice, is taking larger pieces and breaking them down, which I am also doing. But this is what Michael's up to. And I like the power piece here, blowing the bricks off into space. And these are nanite, can be nanite as well with our Nanite Niagara in a single draw call. So thank you for joining me, my friend. These are some people that helped me with multi-threading as I was starting to learn it in C++. I came over from Unity with ECS dots, which is their entity component and data-oriented programming. And so getting just a little bit of the change from C# to C++ was exceptionally helpful from these two gentlemen, the Red Pixel, going by the Red Pix, and Seth. So if, I just want to wrap them on here and say thank you. So why did we choose the Matrix? Unreal Engine 5 was released. Matrix Oation came out, and I felt like new technology. It's important to jump full speed. There's a real first mover's advantage, even though we're a bit later than it was initially released. Simply put, though, it was the best possible option out, and the best source material someone could dream for when you're doing citywide destruction. So thank you, Epic Games. Thank you to the developers and artists that made it. I got to meet some of them. So if you know Cedric, Jim Van Allen, and Bryce Criswell, they're core members of the Unreal Engine physics team. Bryce was in charge of the destruction for the cars in the Matrix that I'm using, so it was really cool. At JDC, I got to sit down and talk with them for a good bit and show them this demo and go through and it was just glorious because a lot of what they brought up, I'm already hammering myself on. And so I'm like, okay, cool. I'm not using the wrong systems for all this. I'm not doing this massively incorrect. They had a great time talking to me, and I had a wonderful time talking to them too. So. I saw Cedric again here. He's doing the destruction lab as well. So what's my goal? Runtime destruction for cheap. Oh, have you guys heard of Teardown? I got to meet Dennis at GDC too. I got to watch him make Teardown on Twitter. He was doing the devlog as he was building the whole piece. And I'm like, okay, this is going to be big. It's going to be big. Made $100 million off of it. And I got to demo the Giantess with him and see Teardown 2. Scope creep. That's why I didn't want to see Teardown 2, because I'm trying to do this, and he is doing amazing stuff. He had a worm going through voxel collisions that he had made, and he was scaling them, and the worm was AI control for each inch. So scope creep, that's why I got to stay away from Dennis. He does amazing stuff. So what destruction have we reached? So how did I reach it? We got the Matrix sample, Unreal Engine 5 and their teams, and then moving everything possible in the nanite. GPU Niagara for physics, and a CPU pool for good physics. ISM spatial grids for sleeping too, so I do make them into hash sizes based on your location to keep, just like world partition, only I can load and save from there. And it was all done in blueprints. And it's being converted in key pieces now, but that was a flex to use a data-oriented approach, arrays to do stuff in blueprints that, you shouldn't be able to do this in blueprints, I think is what people would normally say. And that's a little messed up, but sorry about the slide there. So how can you benefit from it, or how you can repeat it? I have a Nanite Niagara free on Fab, where it will show you converting from exporting particles from Niagara into ISM transforms, so you can just update every frame, and so it's that whole sample on that whole sample on GitHub for single-threaded. If you do want the multi-threaded one, that's up on Fab as well. Spawning particles to Niagara is up on GitHub. You can look at that piece as well. Overdraw XYZ, and I'll point at him, has a GPU collisions free tutorials to go through that will help you do your GPU particle collisions in a 2D grid, and then roll your own glue with CPU pools. So this is the tutorial that Ryan put together on particle collision. You can watch about an hour long on there. So that's exactly the system I use for my particle collisions by scaling the bounds of each particle I'm simulating. And then what we need to be doing to improve it, converting from blueprints to C++ at key areas, although we really should just do the whole thing, but it's a really big blueprint script, okay? So it's just taking me some time. More pooling, such as pooling my sleeping static ISMs. Instead of adding new instances or removing instances, if I can just figure out in my mind, I think I'm just off by one, how to trace that, where my empty amount or pooled instances are versus the ones that are in use, then it will really increase your add remove speeds to not actually be adding or removing at all. You're just removing transforms. Smoke. So over there, single Niagara system, sending in where to put a smoke particle. One draw. So my smoke is all one draw. And same thing with decals. Neil DeWitt has a tutorial that I couldn't find, but about how to use a material and displace it down to, I believe, the screen space, so that I can use it as a decal at mass. So I'm spawning 1,000 decals a frame that live for 6 seconds, and these are transparent decals because of this on a rendered cube that displaces it down. And so I have as many decals as I want, the timer as much as I want. It's handled by one Niagara system. How to think like me. We want to ensure we always reduce instructions. Every option that you enable on your systems is additional data that you have to cycle and process somewhere on your server. This is extra work. Only enable what you need and disable anything you don't. And this is a Fortnite prop, but it's the same thing for them, is disable, get rid of all the data you don't need. Because it's all extra cycle work, extra data to be done by the system. More cycles down there, the more data you gotta crunch, the longer your frame time is gonna take. So as much as you can cut out anything, it's gonna make that it happen quicker. So get rid of any little piece you don't need. And this is just showing more data cycles, bigger frame times. Reduce your most impactful systems first. So if you don't need shadows on an object, consider it. Turning off shadows, turning off collisions for the objects, not playing animations or world position on the objects. Is it part of gameplay? Is it going to be networked? Are you going to replicate this stuff, or you turn off replication for it? All these things are what add up at different rates to impact your frame time. Example of it, we have 20,000 actors here. You set them as movable, 20,000 draw calls. If you just select them all and make them static, it allows automatic dynamic instancing to turn them into ISMs per frame for free, and you get less draw calls. It's not perfect. But if you do, say, use HLODs and make grids out of it, we're using less components. We're actually getting less draw calls because of that. You see how much of an improvement the frame rate gets. We still get the same visual. We can even still have the same collisions, but not movement. It's all in the like for like. As you're turning down the complexity of the data, the quicker it will cycle. And Unreal Insights, hopefully you're all pretty familiar with that. If you're not, go home and use it. Make something simple and look at it. It's going to tell you how much anything you add to your game has a bar and how much it impacts. Yeah, it's a tool that shows how long data takes to cycle as the length of the bar from left to right. And so that's what we're going to see here. As we're reducing, the bars are getting smaller. And that's because we're dealing with 20,000 components on these two yellow ones. Where with my H-loads over there, I'm probably dealing with 5 or 6 for the space we were in, components instead of 20,000. The 20,000 is taking time to consider my occlusion culling, my shadows, if they can see each other, all this stuff the engine's having to do just to consider these things because there are 20,000 components instead of one component that's handling itself like the ISM does. And then, yeah, the difference here between a HLOD or ISMs generated by world partition versus one by hand, the draw calls are less because you have less components. If you have one component, it can just be one draw call. It's 36 instead of just one because we have 5 for the stat display there. So it's just one for the one ISM. So what's the point? If we have 20,000 actors, there's a massively different performance based on what you can enable on it, so it can show up. If we just hide them, we still have an impact for physics if we're doing movement or not, even though they're hidden. Also, if you have them checked off for streaming, they're still going to be streamed in, even though you can never see the things. So it's all these considerations of do you need to stream this thing and where the impact happens. Because anything you check off has an impact. So you always want to reduce your instructions. ARI, always reduce instructions. So I got some pins on these too. I love ARI, he does great work. So how I learned ARI, 4 years ago, I set the goal, roughly 4 years ago, to do something hard. More than just a game, I wanted to do the impossible or make the impossible possible. And to become a game dev, as weird as that sounds, and move the industry forward. I'd be cool. I think we all want to do that. That goal became unlimited destruction. Destruction means everything remains in the world and does not dissolve. And all I could find in games is, dissolve some of it, and I dissolve some now too, but just small pieces. We started with chaos collections. I think we may all. It has a soft limit to about 4,000 because it is simulated on the CPU. You could go ahead and increase that soft limit, but you're just going to have more work on your CPU on the game thread. Can we increase the soft limit? That's what I'm saying here. Pooling chaos collections is something I'm trying to figure out. And I've talked to Cedric about it. He showed me some spaces I could go look at for resetting them. Because when you spawn, I want to fracture up the large cat bash pieces that I have. And how I do that right now is I place a template. So I have my big wall there, and you see some smaller pieces. That big brick wall will break into those smaller pieces after it takes a couple hits. But they're all the same brick walls, the same pieces. So I'm not using a unique fracture for each thing in the whole world. I'm using the same pieces, so actually the world gets simplified as we do destruction into the same meshes. And here you can see during that bus part here, we're just pushing into many overlapping ISM walls, because I just wanted to hit this with the worst thing you could think of. And so as it's pushing around in there and putting stresses on that, seeing that the decals I'm using there, just one draw call and that one material as well being used down there. And also the smoke is all doing the one draw call material as well. And we're breaking these things up and they're simulating around it and so on. Static mesh physics instead. What about just CPU? Oh, we covered this. Sorry, it seems to match. So yeah, if you make 1,000 CPU actors and use those, or you're using geo collections and destruction, it's still having the same impact on your CPU, is what I found from testing it out. If I make components, can I make it lighter? Except for if the skeletal mesh aspect does add extra load. Subpools. So as I'm pooling my meshes, I would just throw them into one pool and I need a new mesh, I grab the actor, reassign it. The assigning the mesh and the assignment of the material is a big hit. So instead I make subpools. If I need that same mesh, I look first. So I can then just grab the mesh again and don't even need to do the assignment. So that's super quick. And so that made a huge impact to do that, because especially I'm using the same 13 or 14 meshes, it's pretty easy to always have them already there. Are we in Niagara yet? So when did we able to move to Niagara from the following ISMs and get rid of the following ISMs? As of 4.2.2 to 4.2.5 when I started, you couldn't export from the GPU simulated Niagara over to blueprints or CPU at all, or at least from what I found. But hopefully someday we could. So I'm always keeping in my mind, I want that. So we had bulk. We needed fine collision for human scale destruction. Sorry about the slides here. I created a superhero game dev destruction to destroy buildings with my foreheads flying around, but I found the lack of fracturing the meshes to be too distracting, and I find some options for more refined collisions. But here is that superhero flying around. So here we have the same buildings before, but we have that superhero template that you can get that's really beautiful. And I'm doing a wake up in front of me just to convert anything into a CPU pool right here, and then falling ISMs. So as I bust into this thing, we do our simulation, now they're all free falling ISMs again. But small scale fracturing. We want to use chaos collections to break up our kit bash. The kit bash pieces are too big for scale as they are right now. And so either we do that or we need to become a giant. Small cell fracturing that we do use right now. So I work with generated templates where I'm putting those 13 pieces so that I can place them where my wake-ups are. So that way I keep the same memory impact for the mesh and materials instead of having to do fractures with geo collections. And instead of in the custom pieces. And I would fill in an ISM with locations from the template. So I have an ISM, I just put transforms into it. I don't really need to set the mesh, because then I'm putting that ISM wherever my kit bash piece is, rotating it and scaling it there. Then I grab all the transforms off of it, rather than doing the hard math of figuring out what the calculus is to rotate all those positions by other piece. I'm just having the ISM do the rotation for me. So that cut down a lot of that math. So we would like to use chaos collections to break up our kit bash pieces, or we're going to stick with that and become a giant. Oh, am I going backwards? I'm sorry, I was going backwards. So here's what one of those templates looks like. I have my rebar and some concrete just sort of on top of where the like a wall piece was. And so I would put those transforms on that floor, actually. And then as I break up that floor, I have more pieces to break up. But there's no skeletal mesh or joints that holding it together. There's no stresses right now. So pulling out of falling ISMs and moving to Niagara, as of 4.27, which was kind of, I think, like the last release for 4, they added in the ability to export back out from Niagara. There's a content sample for that version and all the ones further. If you go to the advanced particle level, emitter 4.2, it's called Blueprint Export of GPU Niagara Particles. So you can just, there it is, epic example. That's what I started off with. I refactored to use Niagara at that point rather than doing the falling ISMs, as a GPU always beat the CPU from my point of view, even though falling ISMs is pretty efficient. A mix of these systems is planned for the future because of that efficiency. So I'd like to have GPU, also CPU, and then falling ISMs, but I need to bench and see if it's worth it. Because if I could just use Niagara, then I don't need that whole system. And that's what I'm doing now, I'm just using Niagara. So here's that example as well for a visual of it. So we now use CPU actors from the pool, overflowing to GPU Niagara by spawning stuff over there and setting meshes. Soon I'll expand this code to allow for exporting of GPU particles with velocity. Now the particles only come out when they're sleeping. What I'd like to have them do is, when they're close to the player, also come out with a velocity so I can send it back to CPU simulation. That way I would literally just be walking around CPU simulation and then have out here GPU simulation around me. So dead Niagara particles export their locations to blueprints/C++, and are saved to the world as an ISM that we can re-wake up and re-simulate. So it's just always cycling. Niagara GPU simulations will always beat C++, 1-to-1. Falling ISMs have some advantages, but lack the rotations that make them kind of stick out. Falling or moving ISMs may be useful for total building collapse or synced large actors. So my Giantess should be able to push a building over, or superheroes should be able to carry one around. And so you can do that with ISMs as a collection of components, so I'll be using it for that aspect. Here's what my Niagara system looks like. I just wanted to show a size. I think, to me, it looks pretty small. So my particle physics over here, you can see I'm not even rendering it. The mesh renderer is turned off. I just have a sphere up there because I just send in an index. I'm sending an index of what that mesh is. We're doing a simulation, and I'm sending it back out with that index. So I never even put the data in there about all, you can do unlimited particles. So we're at 10,000 index count right now. But I only have 2,600 meshes. And then that, on the far side over there, that's my smoke VFX. And I don't even have that. Oh, I turned smoke off for a video. So that should be turned on for the renderer. But the neat piece about the smoke, besides that it's a unified system, one draw, that I'm sending positions to spawn smoke at, is that I also have a particle random value that I set on that particle that lets me select what flipbook texture I use. This way, you could have fire, you could have smoke, you could have water or sprites or whatever being sent to Niagara, being drawn with that one draw call, and it's unified. And here's how you can set that random value. So it's not actually random, it's material random, you just set it. I'm passing in a packed value there, and I'll show that a little bit. We're packing data. So packing data, over here I'm showing on my map that we have our vector where our location is, our mesh rotation, which is the orientation, how it's rotated, if it's alive or dead, because we're exporting alive particles every frame, and also when you die, we export you, so I need to know which. And then your mesh ID index and your scale. All that gets packed into a position and a velocity and a size, which is my export data. You could use multiples of export data. That would be where I'm doing that. I can export the velocities. So that'd be that next step to tie those together. But using just a single node per call, I pack it all into those pieces. And that's what this looks like, where I'll pull in the data, start to cull the behind the decimal one, and add my value behind the decimal. So I get two types of variables into one value. It's called packing. So is it all put together? We wrote a plugin on GitHub and Fab that converts Niagara exported particle positions to Nanite ISMs. This brings Niagara particle mesh rendering to Nanite. With skeletal Nanite meshes coming along, well, they're here now, just smoke and transparencies will remain outside the Nanite family. Here's what that plugin looks like. There's a free version, single-threaded, that you can get. It's with full details on the Unreal forums and on my GitHub. And if you want the multi-thread, it's up on Fab as well. And it does have exporting. So we're not just so you're getting the every frame, what the action is, but also when it falls asleep, I have that in there too. So you get both pieces packed in. And this is where I'm just showing that I'm passing whatever index I want for the particle. And that's what it will just have an index. Collisions for particles. We're using mesh distance fields. My Giantess looks like that, like a fridge or something. We're going to, of course, cut up the mannequin or our models at their joints and then attach them. Because that's what this is. I just have colanders attached to the different areas of the bones. And I have a material on there that generates mesh distance fields. It's a masked material, and I have it fully masked, so it's invisible. So that way we get mesh distance field without having to be rendered at all in the environment. And then that's what our particles collide with. Our CPU simulated actors also generate mesh distance fields. So then our CPU pieces can push around particles. And the particles are collapsing with themselves through that 3D grid piece from Ryan. Oh, she moves a little bit. Nice. Blueprint to C++. So I was coding my system in blueprints as a challenge. I wanted to see if a data-oriented programming methodology would overcome blueprints and overheads. It does. But of course, moving that to then the data-oriented code, then to C++, is another 100x multiplier. So I mean, that's just good news. So then that's what we're doing. I'm now converting key aspects of the system. So I did say, of course, well, when you do this, loops. Loops are are the main area that you're going to want to convert over to C++. Now, when you're doing that conversion, you want to look at Unreal Insights and also look at your code and say, what am I needing to do every time in this loop? If you're getting a variable instead of storing a variable outside the loop, that's extra work. So you can, in blueprints, do a lot to make sure you know what actually needs to be in there before doing the conversion, because then you have the least amount of nodes that you have to convert, plus the thinnest. Because you're just trying to do the things that are high transaction, like thousands or hundreds of thousands of things, you gotta do it in C++. Because of the overhead. Blueprints just has overhead between your calls. So a whole world of instances. The whole world is made out of ISMs, not HISMs, components that are multi-thread safe. Oh yes, ISMs are multi-thread safe. Of course, you have, meaning as long as you keep them in a thread. So if you go ahead and do a parallel for on a bunch of ISMs to say, get all overlapping instances within a sphere, you could do that and get all the instances from each one parallelized rather than having to serialize it out. And so that's across multiple cores. That's a huge thing to get, to be able to add, remove, get overlaps across like that. So I made a C++ call to do so. Get instances from these ISMs by sphere. So the matrix small city sample is made of instance static meshes for optimized rendering and scene reduction. So if you did do HLODs, it would just make an ISM anyway. I directly reference the ISMs within each cell rather than using physics to do so. So I'm not using a physics call. I have my own quadrant grid system, do my own hash off the location wherever I want to wake stuff up, get that grid, get those ISMs. This is all, I'm really looking to do this as a way that the matrix awakened sample, it was stressed. And so I was saying, how can I do total destruction and hopefully not add anything to it, anymore? It's a ridiculous thing to ask, but we got there. So with the addition of that unified decal system, unified VFX, we obtained an always active, low overhead and unified destruction system. Each pooled CPU actor is infrequently checked for impacts, which triggers sound generation and decals. We call get overlapping sphere instances on our ISMs, and each sphere on at a scale to match our growth. So as she gets bigger, the spheres we wake up around her get bigger. We can pass in any amount of wake-up locations. Of course, the more we put in, there's some load, but it's multi-threaded work, so it works pretty well. And here's a picture of the overlaps that we're doing. You can see there's some spaces mixed as she's growing between like her hand and her shoulder. We just need to put more there. But I don't know if I think I might have a walking one later, actually. But just mainly showing that it's attached to sockets. So we do allow VRM uploading in our current Patreon setup. So you can upload your own models, upload your own animations, and it just works with the entire system. So we're going to look at how pieces sleep in the world, because we have buildings and we have our quadrant. And when we collapse our buildings, we want anything that landed on the building to also collapse with it. So blue, we're going to see a blue sphere. That means it landed, our sleeping mesh said, hey, this is a building. I'm part of this building now. We have a green one. If it says it's not a building, I'm just sleeping to the world. And then red is if I found a piece of the world and it wasn't ever a building type of thing. So it's just green and blue, or green and red are about the same. So she's just going to walk into this stuff here. You see some green going on down there. I want really to focus on the blue. Blue inside the buildings. Oh, some more green. Maybe they are floating. Just some debug for me to figure out. And then when that building would collapse, all the blue pieces that were slept to it will also collapse with it. And we might see it collapse. I'm not sure. There we go. And on that collapse, we just do a multi-thread grab on all the ISMs there, get all their transforms, and feed them all over at one call into Niagara. And then it does all the simulation. So small scale breakup is something that we have to complete, or have been completed, but it's just I'm spawning extra components. So I will spawn just more pieces wherever that big piece is. The big piece still stays there. So we need to really mesh fracturing is the thing that's been what I've been working on or needing to do for the last several years. And so the next area I'm working on is that fine fracturing. That's what Michael Royalty up here has been helping me with as well. Is how to use chaos collections or some other area to reset or pool them and then export the pieces to ISMs and into my own system. Because I'd love to, if you have 50 pieces in a piece, that's fine. Just give me the information on where they are and let me reset that piece. And so maybe, I haven't figured it out completely yet if it works. Given these pooled destruction systems, we want to provide a hitchless destruction experience unlike seen before. Additional time is needed to be spent on aligning all these systems with unification. With UE55, we can enable skeletal meshes for skeletal mesh support, so all the metahumans, all the cars, and also my character, my giantess, can all be nanite as well. That gets us all in there. That's part of the upgrade to do. Victor here is the creator of the voxel plugin, so I love Victor's voxel plugin for destructible landscapes. And meshes by visual graphing, so it's like a visual graph piece. The main part here is voxel plugin 2 is coming out, and that's going to be completely nanite enabled as well. So what I will use it for is, I don't have the piles. So when you collapse a building, the whole building piles up. And that's a heck of a lot of nanite overdraw, right? So what we do right now is we have one mesh, there's a pile of rubble, and that rubble does some overlaps to look for pieces. It grows in size and deletes the pieces to try and calm down the amount of overlap we get. Using the voxel plugin, I'll grow the voxel ground and destroy the voxel ground. It'll have a lot more, it'll look a lot nice, a lot more smooth, and of course, be nanite as well. So that's something we're working on moving towards. But I love to rep it. So I saw Tim up in Seattle. First thing he said to me, "Hello, Micah," which was freaking sweet. "You have to release your game. You have to find a way to do it, any way to do it. $20, anything, just release your game, you have to." And so I found a partner, the person who I've been helping and gave me that pay, and showed him the plugin that I just released, and he said, "Hey, let's work together." So I've been working with the Giantess plugin. Oh, I want to be an Epic exclusive. I'm a 21-year-old Steam veteran, and I got a lot of stuff to it, and yeah, I'm over here because I want to be part of this. So, the environment. Just wanted to say that. And Epic was so excellent to me, which is they sent a letter to GTS, my partner in China, asking him to come to the conference, an official Epic letter saying, "Hey, this person is important to our industry. We'd like to have him come here and join us to talk about," because he does all the IK, all the animation, all the menu stuff. You can ask me about the IK stuff. I'm not going to know anything about it. I'm going to say it works. I can talk about the other piece. Sorry if you're here for IK. So thank you, Epic. It really means a great deal to us. So thank you. So what's next? I'm looking to bring forward this with partners, possibly a mega grant that's been submitted. The Epic mega grants to fund my destruction efforts. You can see Star Wars, we have Star Destroyers, lots of different things I can do with the destruction. Here's my phrase, my quote: "To be unstoppable, just keep trying, everyone. Just keep trying." So the Giantess Playground is in production right now, Godzilla-like. So we already just put the mesh in there and we got Godzilla. And we can just go ahead and wake stuff up with fire. So we already have the mesh in there. Hero-like is that superhero piece, roadless. This is my magnum opus I'm working on. So that would be fully destructible, and that's where we started. And I said, I don't want community management, that seems too heavy. So we went to single player. So that's I have a bunch of stuff on it, but that's not this talk. And then Speed Up was the bus-based one. Might be retired, maybe not. So I guess that means I finished it. And then what's next? Let Tim know you like this, or let me know you like it if this is worth it. I'd love to share this with you and be part of destruction games or part of stories being told. You don't have to destroy the entire environment. You could just, whatever destruction you're doing, I'd like to lighten that up. Make it not be an impact. So now you're like, oh, we have to destroy this dam. It only took nothing. We can do 5 dams, 6 dams, 100 dams. Make it trivial. That's the idea, make it trivial. Hold up to Maury. And also, wanted to go ahead and say thank you to Justin. He was my mentor that taught me all this optimization, so I like to be better. So we'll go into questions. Sorry about that, but and thank you for joining me on this. So yeah.